this video, we'll continue our study of the slopes of linear equations, the slopes of lines, and in particular, we will look at perpendicular lines and how their slopes interact, parallel lines and how their slopes interact, and then we'll hit an important concept called the rate of change, or the average rate of change. This example in our note page is the type of example that you would be able to complete by the end of this section. Here are our learning objectives for this unit, and you can see that learning objective 2 and 4 both tie into the section 2.4, more on slopes. Describe the rate of change of quantities and determine equations of lines given 1 point in the slope and 2 points, or statements about proportional relationships. And here is our first example. Write an equation of the line that passes through this point and that's parallel to the line whose equation is y equals negative 4x plus 3. So the first step is to look at this y equals negative 4x plus 3 and recognize that the line we're looking for, we have a point, the negative 8, negative 10, and now we can use this parallel line, y equals negative 4x plus 3, to determine the slope of our line. Now parallel lines are the same. So if we know that the line we're looking for is parallel to y equals negative 4x plus 3, then we know that it has the same slope as y equals negative 4x plus 3. And when we look at this line, it's already in the slope-intercept form, so we know that the slope is negative 4. So we can pull from this example, we can pull from this description of the line that we're looking for a line that goes through the point negative 8, negative 10, and that has a slope of negative 4. That's the first step. Now the second step is to review what we've done in the previous sections, and that's either using the point slope form of the equation, where we'd say y minus y1 equals m times quantity of x minus x1, and we're going to replace the y with negative 10. So negative 10 subtracted, it's going to be plus 10, right? We had y minus negative 10, so that's the same as y plus 10. The slope is negative 4 times the quantity of x minus negative 8. So once again, we could change that to adding an 8. So minus negative 8 is the same as plus 8. Now if we solved this for y, we'd get our equation. But let me show you another way to do this also. We could also just use our y equals mx plus b. And we're going to replace with m, the negative 4, replace x with the x of our point, and replace y with the y of our point. So if I do this and solve for b, I'll have the equation also. So let's try it this way as well. So y equals, oh, I'm sorry, didn't replace the y, did I? So y is negative 10. So we have negative 10 equals m, so negative 4, x, negative 8, plus b. And you see how I can solve for b? Negative 10 equals 32 plus b. If I subtract 32 from both sides, I'd have that b is negative 10 minus negative 32, so negative 42. So now that I have an m and a b, I can write the equation of the line we're looking for is y equals mx plus b. So here's the answer. Going back to the point slope, maybe you've already solved that. We'd have y equals negative 4 times x, negative 4 times 8. and then subtracting 10 from both sides, we'd get the same result, y equals negative 4x minus 42. You could use either of these two formats. You could use the point slope or the slope intercept to find the equation, to finish solving this question. Pick the one that works best for you. The reason that I prefer the y equals mx plus b is because then I'm not left having to remember another form. I don't have to remember the y minus y1 equals m times the quantity of x minus x1. This next example is very similar. Our line, the line we're looking for, passes through the point 4, negative 7. And now what we need is a slope. So we aren't given the slope, but we're told that we're told that this line that we're looking for is perpendicular to this line x minus 2y minus 3 equals 0. So what I'm going to do with this line that we've got is I'm going to solve this for y, because if I solve it for y, I'm going to have the slope-intercept form of the equation. And if I have this in slope-intercept form, and then that's the y equals mx plus b. If I have it in that form, then I can pull the slope right out. So I'm going to start by subtracting x and adding 3 to both sides. So now I have negative 2y equals negative x plus 3. And then to solve for y, I'll divide by negative 2. So again, what I'm doing with this perpendicular line is I'm solving for y. The reason I'm solving for y is so that I can get the slope really easily. So I can see here that the slope is negative 1 over negative 2. Which is equivalent to 1/2. Do you see where I'm getting that? I could draw in that one. Negative 1 over negative 2 is the same thing. If I divide both by negative, that's the same thing as 1 over 2. So if the perpendicular line has a slope of 1/2, then the perpendicular slope is going to be the opposite reciprocal. So, and I'm using the symbol, an upside down capital T for perpendicular, but the perpendicular slope, I'll flip the 1 over 2 and I'll change it to its opposite. So I know that now that the line I'm looking for has a slope of negative 2. What I could do next is use the y equals mx plus b slope-intercept form of a line, given that the slope is negative 2, x is 4, y is negative 7. If I fill those in, so I'd have negative 7 equals negative 2 times 4, y equals m times x, plus b. Solving for b, negative 7 equals negative 8 plus b. So adding 8 to both sides, I'd get that b is equal to 1. Now I have b equal to 1, m equal to negative 2, so I can write the final equation as y equals m x plus b. So y equals negative 2x plus 1. That's the slope-intercept form. I could also write this in point-slope form, because I think this one asks us to give the answer in point-slope form, so I could also write it in point-slope form. Y minus y, so y plus 7, y minus negative 7, so y plus 7, equals negative 2 times the quantity of x minus x. So y plus 7 equals negative 2 times x minus 4. And in general form, that's putting it equal to 0. I'd have negative 2x on the right So what I'm going to do is I'm going to add 2x to both sides. Let me write that out. So we have our y equals negative 2x plus 1. If I want to set this to 0, I'm going to add. So we have this negative 2x on the right. So I'm going to add 2x to both sides. And I'm going to subtract 1 from both sides. Sorry, it's getting kind of tight fitting it in here. But here's what that would look like. It would be 2x plus y minus 1. And then we have equals 0 on the right side. So here's our 2x plus y and minus 1. And then the 0 on the right side. So we have our slope-intercept form of the line, point-slope form of the line, and general form for the line. Let's look at another example. And this example is a application problem that interprets slope as a rate of change. So in 1994, there are 617 active duty servicemen who were discharged under the Don't Ask, Don't Tell policy. And then in let me write these down. So 1994, there were 617. And then in 1998, we have an increase, 1,163. And use these ordered pairs, 1994, 617. So when the year is 1994, the number of service members is 617. And then in the year 1998, it's 1163. So we have our x and our y. Use this ordered pair to find the slope of the line through the points. Express the slope correct to the nearest whole number and describe what it represents. So if we used our m equals the change in y over the change in x, we're going to have m equals 1163. It's our first y, or I'm sorry, the first y in our slope, but because it was our second y, it's what we increased to. So 1163, that's the y2, minus 617, the y1, divided by 1998 minus 1994. So if I do that subtraction, I get 546 over 4, and then when I divide that, I get 136.5, but the directions ask us to give the slope to the nearest whole number, so I'm going to round this 6 up to 7, so approximately 137. And notice that it's positive, which is what we'd expect because from 1994 to 1998, we had an increase. So we knew it was going to be positive. And what does this tell us? It says that an average increase of 137 service members a year are being discharged under this policy. The average increase is 137. So we could use this to make a prediction that if something doesn't change, then in the year 2023, we could expect the number to have grown to X number of service people. So we could use this increase to make predictions about the future. Let's look ahead at another example of rate of change. So here we have just a description of rate of change from the textbook. If you didn't already read this, I want to encourage you to pause the video and read this example more carefully. But then we have the rate of change formula. Apply the rate of change definition to this. So we have find the average rate of change from f of x equals 3x, for f of x equals 3x, from x sub 1 equals 0 to x sub 2 equals 5. So we want f of 5 minus f of 0 divided by the difference of 5 minus 0. Now the first thing I have to be able to do off to the side here is I've got to be able to calculate f of 5. And to do that, I use that f of x is 3x. So f of 5 is going to be 3 times x, so 3 times 5, or in other words, 15. And then f of 0 is going to be 3 times x when x is 0. So 3 times 0, or 0. So what we have here is f of 5 is 15. F of 0 is 0. So 15 minus 0 over 5 minus 0. 15 over 5. Which is 3. So the average rate of change of y divided by the change of x, is going to be 3. Let's try another example. And did you catch that the first step really was to evaluate what the value of the function is at each of those places? So in this example 3b, we have the average rate of change is going to be f of 5 minus f of 3 divided by 5 minus 3. So what is f of 5 in this example? In this example, f of 5 is going to be 5 squared plus 2 times 5. So it's f of x is x squared plus 2x. So we're going to take this 5 and replace the x with 5. So 5 squared plus 2 times 5. 25 plus 10, which is 35. And then we're also going to need f of 3. F of 3 is 3 squared plus 2 times 3, right? So we take our function x squared, replace the x with 3, 2 times x, replace the x with 3. So we're going to have 9 plus 6, or 15. Now I can take those numbers and replace f of 5 with 35. F of 3, replace that with 15. Divided by 5 minus 3. 35 minus 15, 20. Divided by 2. So it looks like the average rate of change, the change in y with respect to the change in x, is 20 divided by 2, or 10. And then for the last example, if the f of x is the square root of x, we can find the rate of change from f of 9 to f of 4 by subtracting f of 9 minus 5, 4, and then dividing by 9 minus 4. So again, we need to start by evaluating the value of the function. So f of 9, if f of x is the square root of x, it's going to be the square root of, and then fill in the x with 9. Square root of 9 is 3. And then f of 4, square root of 4 is 2, so 3 minus 2 over 9 minus 4, so that's going to give us 1 over 5. So the average rate of change, for example C, is 1 over 5. I hope that these examples have helped you. Here's the answers if you want to be able to look back at an answer key. Hope that these examples have helped you. If you do have any further questions about the topic, please reach out. And make sure you get in some practice, because watching a video fly by with someone else working out the examples isn't as beneficial as jumping in and trying the examples and thinking through the examples yourself.